friends, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Yes, that is right. We are hopping on the March Madness bandwagon. Now, if you see the title, if you listen to the podcast for long enough, you might be thinking, wait a second, programming languages March Madness. Well, this is going to be an absolute snooze fest because we already know exactly what the outcome's going to be. He's just going to pick C or C++ because that's his favorite programming language, and we're just going to call it a day. But to be fair, that logic would be sound. However, that's also like saying, I believe that the Chicago Bulls are going to win the championship this year because they won 6 championships with Jordan back in the 90s. And I hate to break it to you, but if you've seen how the Bulls are doing this year, they're not doing so hot. And I don't think they have a really good shot at winning the championship. So, while yes, C absolutely dominated historically, that doesn't necessarily mean it's going to dominate today. Now, with that said, I just wanted to kind of ask you guys what your brackets are, what your winners are, for which programming languages you think would win in a March Madness style head-to-head. So let me know what your brackets are, who your winners are. If you're on YouTube, you can let me know in the comments down below, or you can always shoot me an email at contact@darkassassinsinc.com. And if there's some good ones, I will definitely be sure to incorporate them into the show. But with that, let's get into our trivia question for the week. So in the theme of programming languages, Rust, Go, and Swift are 3 memory-safe compiled programming languages that, in part, aim to replace some of the C/C++ historically dominated application spaces. Out of these 3, which was created first? So between Rust, Go, and Swift, which was created first? And bonus points if you can get the year that the first one was created, or any of them were created. So that is your trivia question for the week. Now, you probably heard that music and were wondering what the heck is going on. Well, this is a new segment that I wanted to try and introduce into the podcast, which I am calling the Open Source Highlight. Now, this isn't going to be an every week type thing, and to be honest, it might not even be an every month type thing. But the goal is to highlight open source projects that I come across and happen to use, because as you all know, if you've listened to the podcast long enough, I am a huge fan of open source software, and wherever possible, I try to use open source solutions rather than paid for, or, well, some open source solutions are paid for, but proprietary mainly is the reason I try to avoid proprietary solutions where possible. Now, whether it's applications, services, libraries, whatever, I try to use as much as I can. I mean, basically everything I run in my home lab is open source. That's an application, a service, an operating system. Aside from like the couple of like Windows servers that I have running, mainly just for like development environment purposes. Basically every every service I run in my home lab now uses Linux, aside from those edge case, like couple Mac OS and Windows servers specifically for development purposes. But anything like service related, like the Jellyfins, the Pi-holes, the VPNs, those kinds of things, all those are running on Linux, because Linux is obviously the best server OS in my humble opinion. But kind of the point of this segment was to basically use as a platform to highlight some of the open source projects that I recently discovered, tested, and really like. Because one thing with open source is some open source projects are very widely known and a lot of people use them. But then you have other open source projects too that nobody really knows about, but at the same time, they're like really fantastic pieces of software. And it's in some cases just a solo dev just kind of doing it as a side project. And he's just having fun with it. And it's a fantastic program. And not many people know about it. And then oftentimes what'll happen in these kinds of situations is if the app does happen to like blow up and get really big, the solo dev kind of gets overwhelmed because he's not used to, all these requests for features and bug fixes and all this stuff. And he's just like, I'm just doing this in my free time. But anyway, so that's kind of what the goal of this segment was. Now, personally, I daily drive a Mac computer, which I fully understand the irony and the hypocrisy here because I literally just was talking for the past couple minutes about how I love open source projects and pride myself on trying to use every kind of open source solution I can, yet here I am daily driving a proprietary operating system. So fully understand the irony and the hypocrisy there. But the reason why I bring this up is because one of my favorite features on the Mac, which I think on certain Linux graphical environments, I think they're kind of bringing this in some, but basically it's this idea of Quick Look. And if you're not familiar with what Quick Look is, it's basically if you click on a file in macOS and hit the space bar, it'll kind of give you a preview of what that file will look like, sound like, whatever the case is. So for instance, if you have a text document or a Word document or something like that, and you hit the space bar, it'll kind of give you a preview of what the document will look like. If you have some sort of audio file and you hit the space bar, it'll start playing the audio file. Same thing with video files as well. It'll start playing the video file. So things like this, it's very handy and very nice because you don't have to actually open up an application in order to just see what the file is, especially for things like text and Word documents and PDFs for that matter too, because more often than not, I just kind of want to check something real quick and I don't want to have to go through the hassle of opening up the app, waiting for it to load, and then trying to find what I want to find. I just want to check it real quick, find what I want, and then be on my way. The problem is, I am a big fan of and prefer to write my notes in Markdown. So when I take notes on like any of my computers, typically what I'll do is I'll write them in Markdown. And Markdown, if you're not aware, I wouldn't go so far as to say it's a programming language. It's kind of like HTML in a sense, where it has its kind of quirks and its own, I guess, syntax, if you will, to make things styly and look a certain way. But there's really no like for loops or classes or anything like that. But it is something that you do kind of have to know the, I guess, syntax, if you will, to make things format pretty in a proper Markdown editor. But the problem is, macOS doesn't natively support previewing Markdown files, which is very annoying when basically all of my notes type things are in Markdown files and I can't readily just, hit the spacebar and view them. And I was quite annoyed with this, and this honestly has been an annoyance for several years now at this point. So recently I found a solution and it's called QL Markdown, and I'll have the GitHub linked down in the show notes below if you're interested in checking it out. But basically what it is, it's an open source quick look extension for previewing Markdown files. So it also has like some customization features too, so you can add support for different things in Markdown, like different Markdown features. Like for instance, one thing, typically when I'm like writing and editing Markdown files, because up until this point I had no way to preview them, typically I would use something like VS Codium to write the Markdown files, and then VS Codium had like a preview window where you could kind of preview the Markdown. but it didn't have support for all of Markdown's features. One of the big noticeable omissions was things like emojis, which, no, I'm not doing a bunch of random emojis in my notes, but for things like notes or warnings or things I want to call attention to, typically, or like a tip, for instance, I'll put something like a light bulb emoji, or like, like a warning sign emoji, or like the information eye emoji or something like that, just to kind of like draw a little more attention to it. But of course, in VS Codium, that doesn't actually display properly. So QL Markdown allows you for support for these kinds of features. So emojis is one of them, syntax highlighting, superscripting, subscripting, math. There's a bunch of stuff that it supports, and it is very cool. Another thing about it that's also very cool is it has the ability to convert the Markdown files into HTML files, which is quite honestly, in my opinion, awesome because, to be honest, from now on, I'm probably, anytime I want to write like a future blog post or something for my website, I'll probably just write it in Markdown and then use this extension. And it also has like a command line program to like batch convert Markdown files too, which is pretty cool. So I'll probably just write it in Markdown, convert it to HTML, and then, copy that HTML, paste it into like my blog template, I guess, if you will, that has like the header and footer information and everything. Because that's one thing that this won't do for you, is if you do have like a custom like header, footer, sidebars, things like that, it's obviously not going to include that when it generates your HTML. So you will have to like kind of piece some things together. But writing a blog post in Markdown compared to having to write it in HTML, in my opinion, is way easier and way more preferred. Now, granted, it has been quite a while since I actually wrote any blog posts for my website. Like, if we're being real here, my blog is looking like that skeleton on a park bench meme where it's like waiting for, the Dark Assassin's next blog post. It's like skeleton on a park bench because it's been so dang long and you're dead at this point because it's been so long. Because the last post on there I did check because I was actually curious, was June of 2023, so we're coming up on almost 2 years ago. But that was a pretty interesting blog post, if I'm being honest. Now, of course, I'm biased, but that was how to use the Xserve RAID in the modern day. So another thing, like I already touched on, is the CLI allows you to batch convert Markdown files. So if you do have like a lot of notes or something that you do want to like maybe you were keeping notes for like a wiki of, how to do stuff, and you wanted to throw it up on a blog to kind of document things easily that way, you could literally just, put all those notes in a folder if they're not already, batch convert them to HTML, put them on your web server, and bada bing, bada boom, there you go. Free, easy blog without you really having to do anything. So that is one thing that is super nice. And the other thing too that's really cool for because it's a Mac OS thing is it also has Homebrew support. So if you use the Homebrew package manager, which I do, it's literally a one-line install to get this thing installed on your Mac and get it up and running, which is absolutely fantastic. And of course, if you don't want to use Brew, you can download it directly from the releases page on GitHub, or you can also compile it from source too if you are so inclined. So yeah, I am definitely a big fan of this. And if you're also someone who writes a lot of Markdown and wants it rendered in Quick Look, I can definitely say that I highly recommend QL Markdown. So if you're interested, definitely be sure to give it a look on GitHub. And like I said, I will have the GitHub linked down in the show notes below. And with that, let's move into this week's cybersecurity tip. This week's cybersecurity tip is to understand your own personal vulnerabilities to help protect yourself. And just like computers and software, we humans have our own vulnerabilities. This is why things like social engineering attacks are generally so effective, because they exploit the vulnerabilities in us humans, in our minds, and sometimes in our desire to be helpful individuals, and that can cause us to fall victim for social engineering attacks. So the point for this week's tip is to kind of understand those vulnerabilities. One of the things that you can do to gauge this is kind of like this idea of a curiosity test. So if you're like me, if you don't know something and it kind of comes up, you want to get to the bottom of it. Like if if some random thought pops into my head and a question I have, I typically can't get that question out of my head until I figure out what the answer is. So if you're in this kind of a camp and you get some kind of phishing link of something that looks interesting to you, if your first instinct is to just click the link, that's obviously not a good thing. That's not what you want to do. Don't let curiosity get the best of you. Like they say, curiosity killed the cat. I think that's the saying. So if you're one of those types of people that you see something that piques your interest and you instantly kind of want to get to the bottom of it, phishing attacks can be a common way to exploit that vulnerability. So if you do fall in that camp, like we've mentioned on previous cybersecurity tips, if you ever get a link that you're not 100% sure is legit or not, there's a couple things you can do in order to verify its legitimacy before actually going to the site it's allegedly trying to take you to. The first one is to actually look at the URL itself. Now, one thing to be mindful of is if they have the URL directly in the email, you also want to double check that the URL that they have listed in the email is actually the link they're linking you to, because it is possible to have the link that the quote-unquote URL supposedly is actually direct somewhere completely different. Now, there's a couple ways you can do this. One is like a simple URL redirect. But the other one is like if you highlight the text and right click, you can modify the link or add links. So you could literally just change the link from the website that is displayed there to actually be something completely different. But if you actually copy the link directly and say paste it into a text editor or something, you can actually examine the link to make sure it's actually taking you somewhere where you should be going to. Other things to be mindful is if you ever see shortened URLs like bit.lys or tiny URLs, things like that, you really want to be cautious of those, because there's really no way where you can easily identify what the URL is actually pointing to. So that's something to be definitely cautious of. And really the main thing that you have to be kind of mindful of here is just to slow down, right? Urgency is typically what gets people burned. Typically, especially I know I can speak for myself here, usually the times where I make my most gruesome and horrible mistakes is when I was trying to go too fast to get something done and ended up costing me. And ironically, you actually end up taking more time to do something if you're trying to go fast. There's this concept, I think it's more of like a racing concept, but it's this idea that fast is slow and smooth is fast, or something like that. Basically, the idea that if you're trying to go really, really fast, you're inevitably going to make mistakes and slip up, which is actually going to make you go slower than if you were just trying to, in this case driving, but drive, not trying to go full pedal to the metal, and you're just kind of going with the flow and being smooth with it. So kind of the same thing with cybersecurity. Before you just haphazardly go clicking on links and clicking on things in emails, take the time to actually slow down, analyze it. First off, analyze this. Is this email even legitimate in the first place before you even click on anything? There's a couple easy ways you can do that. One of them is to check the sender of the email. I think we've touched on this before, but check the sender of the email. Is the supposed name that the email might be claiming to be actually them? Check the domain of basically what comes after the @ of the email. Is that actually legitimate? So for instance, if the email is claiming that, it's something to do with your iCloud, is the email actually coming from like an Apple domain, or is it coming from like a Gmail address or some other random address? Because if it's one of those Gmail or random addresses, that's obviously completely bogus and you should just throw it right in the trash. So things like that, you definitely just kind of want to slow down and take a deep breath, kind of make sure that you're actually communicating with a trusted channel before you go, clicking on things. And that's kind of, what it is with social engineering, right? Like phishing is just kind of like the tip of the iceberg when it comes to this idea of social engineering. But like unsolicited phone calls exist too, spam calls exist. I think one of the biggest one, or one of the big ones kind of going around right now, I believe, is like the grandma. I think they call it like the grandma scam or something like that. Basically, like scammers out there trying to like call up, elderly people and basically trying to impersonate, like their grandson or granddaughter or something like that, saying like they're in trouble and they need them to give them money or something, and they want it in like some weird like form. Like, it's not necessarily they want you to like, give like your credit card number, but sometimes it's like, I need you to go to like, the store and buy like a bunch of gift cards or something, because obviously if you're a grandchild, you're going to be calling up your grandparent and telling them, hey, I need you to get me some Xbox Live gift cards so I can get out of this jam I'm in right now, because that totally makes sense. Or maybe Amazon gift cards or Walmart gift cards, because obviously that makes sense. If I'm stranded on the side of the road and my car's broke down, yeah, I need some Amazon gift cards right now to get me out of this jam. So yeah, that's definitely another common one, and that kind of feeds on this kind of social engineering type, vulnerability in us people, wanting to do what's best for people, especially if they're family members. And that's really kind of at the core of what the grandparent, scam tries to take advantage of, is trying to exploit that vulnerability in grandparents, that they want to do everything they can for their grandkids, right? So yeah, definitely understand what your personal vulnerabilities are in order to help better protect not just yourself, but also your friends and family members as well. And that is your cybersecurity tip for the week. Now, we got a lot of March Madness stuff to get into, but before we get into that, real quick, let's get into what nerdy stuff have I been up to this week. So this week, I wrote a very quick and rather simple Python script to monitor my servers to check their ZFS health. So if you'll remember, there have actually been 2 documented cases on the podcast where I've dealt with ZFS degrading issues. The first instance was on my previous NAS, where I had a 3-drive RAID 5 array, and one of the drives failed. And thankfully, because it was RAID 5, I didn't lose any of the data. But the second instance was the more concerning one, mainly because I honestly have no idea how long the drive was dead for. But a drive failed in my Dell R620, and it was an SSD, mind you, which up until that point I've never had an SSD fail. Which I guess also, in fairness, when the drive in my NAS failed, that was a hard drive, and I also had never had a hard drive fail on me before, so I guess first time for everything. But typically you think SSDs are generally more resilient. Well, maybe not, but the thing with this that was weird was I literally had no idea that this drive died, and I couldn't tell you when it died. So the point of this script was basically to constantly monitor the drive health of the pools on my various servers that use ZFS, basically just to check in to see what the status of the pool is, and then basically send me a push notification if they ever go into some other state that isn't online, or basically that it's healthy. So because I have a Notify server set up in the cloud, basically what this will do is it will query my servers, and then I have it currently. I just have a cron job set up to run twice a day is what I have it configured to right now, but I could easily configure that to run every minute, or every once a week, or I basically do whatever I wanted. But I figured like twice a day was probably enough. I don't think I need to do more than that. Honestly, I could probably get away with less. I could probably get away with once a day. But twice a day is a little bit more peace of mind. Because if we're being honest, though, like in fairness, I do have extra drives that I could swap one in. Like if I did see like right now that I get an alert that, a drive failed and in one of these pools is in a degraded state, I could easily right now, take a drive that I already have and swap it out immediately. But in other cases, like in the past 2 instances where I had drives fail, that wasn't even an option. So it wouldn't necessarily matter a ton if I knew immediately when the drive failed, or if I knew like a couple of days later, because regardless, it'd still be down for a few days, if not more than a week, because I'd have to order the drive anyway to replace it. But yeah, so I could run it as much as often as I wanted. It's just like I said, it's a very simple, basic Python script running in a cron job. And yeah, that was basically what I got up to. That was something that I had kind of been thinking about and wanting to do for a while. I don't know about you guys, but I do have like a notes sheet or document or whatever you want to call it of like project ideas of things that I kind of want to work on as just kind of like side personal projects, like in addition to the things that are already established, like my video game, it has its own massive document of notes of, things I want to add, features, and yeah, that hasn't been touched in months. Big oof. But sometimes you kind of got to divert your attention to other areas. So a lot of these types of projects that I've been talking about, like the Server Connect feature updates, the ZFS one, those were kind of things that had been on the, I guess you could call it the to-do list for a while. They just had kind of never got around to it. So I had some time one evening and just decided to crank that out. And yeah, that's what I got up to. So without any further ado, let us get into March Madness for programming languages. So I guess the first question is, how do you do seeding? Now, you can do seeding however you want. You could do seeding based on what your favorite languages are, although I feel like the one issue with doing that is you just are basically going to be chalk the entire time, or basically the idea of you're always going to pick the higher seed to win, which is quite honestly pretty boring. So for impartialness sake, I decided to take the latest rankings from, I think it's TOB, for March of 2025. Now, they have listings throughout, I don't know how many, but for the sake of, briefness, I guess, we're just going to keep it to the Sweet 16, so the top 16 teams, or programming languages, I guess. Now, personally, I am kind of sad that Swift did not make the cut, and it was ranked 26, so that is rather a big oof. The other one that I can't say I'm surprised, because this is rated on popularity, so I can't say I'm surprised, but Assembly also did not make the cut. Now, if we're being honest with ourselves, that shouldn't be a surprise that Assembly wasn't one of the top 16 programming languages, but if we're talking about like importance of programming languages, Assembly definitely has to be up there with the massive role it's played. So getting into the top 16, starting from number 1, we have Python, C++, Java, C, C#, JavaScript, Go, SQL, Visual Basic, Delphi or Object Pascal, Fortran, Scratch, PHP, Rust, MATLAB, and R. So if you're not familiar with how these brackets typically work, you basically have, the highest seed going against the lowest seed, and you kind of like keep doing that until you meet in the middle. So first if we're looking at it's going to be hard to visualize since I'm talking about this, but if you imagine a bracket of 16 teams where you have 8 on one side and 8 on the other side. On the left side of the bracket, you have Python versus R, you have SQL versus Visual Basic, you have C# versus Scratch, C versus PHP, And then on the right side of the bracket, you have C++ against MATLAB, Go against Delphi, Java versus Rust, and JavaScript versus Fortran. So let's get right off the bat with the number 1 seed taking on the number 16 seed, or Python versus R. And if we're being honest with ourselves, this one isn't even close. This is an absolute blowout. I don't think we need to take much time talking about this because, let's be real, R never stood a chance. Python does everything that R does, all the math and statistics stuff. It does all that stuff, but better, and also does way more. So Python is the easy winner in this round. So Python moves on to the Elite Eight. So next on that side, we have the number 8 seed SQL versus the number 9 seed Visual Basic. Now, this one, have you guys ever watched any kind of sports game where the game is just so bad that you kind of feel sorry for the players that are involved? Because that's literally what this is. Because both languages are so niche and so specific. They're both just really bad. Like, there's really no good winner here. Like, if we're being honest with ourselves, it's kind of hard to call SQL an actual language. I mean, sure, it technically is, but anything outside of manipulating an SQL database it's basically useless. Visual Basic, if we're being honest, isn't that much better. Yeah, now, I mean, sure, it has a little bit more versatility in what you can do, like, automating things in Windows and kind of making Excel macros and things like that. But you're not going to be building the next great app in Visual Basic. At least SQL, I mean, you could make the argument you could be designing your application's database with it, maybe, but yeah, both of them, neither of them are very good, but because of the versatility of Visual Basic with how it can do various things for automating things in Windows, I'm going to give it to Visual Basic here, which technically I guess makes this an upset because Visual Basic was the 9th seed versus SQL is the 8th seed. So right off the bat, we have a very early upset, I guess. Now, next in the bracket, we have C# versus Scratch. Now, just like the Python versus R competition, this one honestly isn't even fair either. C# wins in a blowout because Scratch basically has zero utility. I mean, it's useful for like educational purposes, like teaching young people how to program, like the very basic building blocks of building stuff, but you're not making applications in Scratch. It's an educational tool. C# is an actual programming language you can build, real world applications with. You can do game development with things like Unity. C# handily gets the win here. Next up, we have C versus PHP. Again, this is another bloodbath. PHP continues to lose steam. It's honestly, if I'm being honest, I'm kind of surprised PHP was even on the list. Now, if you want to talk about losing momentum, one thing in sports that's obviously like a very big deal is this idea of momentum. Teams that have momentum, even if they're not necessarily the better team, if they have more momentum, sometimes that's enough to get them over the hump and kind of beat out better teams. But then you kind of have the flip side where you have a team that's really, really good, but maybe they hit a slump, maybe one of their players got hurt and they're kind of losing momentum and they just kind of go on this, rut losing streak and they get beat by teams that they shouldn't have any issue, beating. That's kind of like what's happening with PHP here in a sense. It's not that PHP was, ever that fantastic of a language, but it's just been losing so much momentum because, the massive rise and dominance of JavaScript in like the web world has I'm not going to say it's eliminated PHP because PHP is still around, obviously, but it's definitely kind of come after PHP, taken its lunch money, and PHP is just, really not, having much momentum, not much wind in its sails. And sure, C has been under attack too, fairly extensively, with the whole DARPA thing, the whole tractor thing, trying to translate all C code into Rust and all this stuff, and all, the whole memory safety, debate. So C isn't necessarily, have the strongest momentum either, but C is still very widely used, very versatile, and C handily gets the win here. Next up, we have JavaScript versus Fortran. Now, you may think that I will pick Fortran here because of how much of a JavaScript hater I am, which, if we were going purely based on which programming language I like most, I might have actually done that. But again, this is supposed to be an objective view of which programming language is better in kind of a head-to-head matchup. So Fortran, again, kind of like R, suffers from being more of a niche type programming language. Now, sure, you can make like different use cases for it, but typically it's more of like kind of like the science, more that oriented, whereas JavaScript can basically do whatever you want. Fortran can do like some scientific related tasks and maybe even some high performance computing tasks, but JavaScript is quite honestly way more versatile in my opinion. Now, granted, it's bloated as heck, but it works, especially with how explosive web apps have become over the past probably decade, maybe even more than that, maybe the past 2 decades. Web apps have just grown and become so dominant, and JavaScript is basically at the core of that. And you can technically make desktop JavaScript applications. Of course, the big asterisks there is the fact that calling them desktop applications is kind of generous, because basically all they are is you use a framework like Electron, which essentially is just a Chromium browser to display the JavaScript in, or you use like a tool like React Native or something to create like mobile apps. So yes, but yeah, JavaScript definitely does have, in my opinion, more versatility, and obviously it has the wider user base, so JavaScript gets the win here over Fortran. Moving on to the next battle, we have the 3 seed of Java versus the 14th seed of Rust. And if we're being honest, this is probably the most interesting head-to-head matchup we've had in this first round, because all the others more or less have been fairly one-sided and have been basically blowouts. But this one is very interesting because Java, as seen by its ranking, is a very widely used programming language and has a wide variety of use cases, where Rust is a little more niche in the sense that it doesn't have as big of an adoption. But it's also the latest hotshot on the block and is riding some serious momentum, which, as we touched on before, momentum does wonders in the world of sports. Now, Java is nice in the sense that wherever the Java virtual machine is installed, Java will run, whereas Rust has to be compiled for each platform. And unlike, some other languages, C and C++, both Rust and Java are both memory-safe languages, so kind of a tie there, if you will. Now, with that said, I guess since both are memory-safe, the one advantage that Rust has over Java is it's easier to integrate C and C++ libraries in Rust than it is to implement it in Java. Now, it's possible to do in Java, but it's easier to do in Rust with, things like the unsafe keyword. So it's a lot easier to kind of integrate, those C and C++ libraries, which, with how many C and C++ libraries there are, that is definitely a big advantage that Rust has. Now, another thing Java is known for, probably rather infamously, is how verbose it is. It is not known for its conciseness. Now, I believe in some of the latest version of Java, the Hello World program has been simplified quite a bit. But if you were writing Java programs anytime within the past, well, basically ever since its conception until probably 2 years ago, you know how verbose the Hello World program is in Java. And basically anything you want to do, you're dotting into who knows how many nested layers deep before you get to the function you want to call. So that is one other benefit that Rust has, is Rust is a more modern programming language with a very modern syntax. It's a lot cleaner in that regard, at least in my opinion, than Java's verboseness. But the other thing that Java kind of has as kind of a detriment to it is, while it's nice that it kind of has this sandbox environment that allows it to run everywhere, it also has this kind of reputation of, if you will, of rather than write once, run everywhere, write once, exploit everywhere. And one of the common vulnerabilities in the history of Java that had happened is threat actors taking advantage of the sandbox environment and performing basically denial of service attacks by kind of exploiting how the sandbox environment works. Now, Java does have a massive enterprise adoption for sure, but with Rust's kind of up and comingness and the versatility of Rust, the speed, the performance, I'm gonna give Rust the edge on this one. I'm gonna give Rust the win here, and this is going to be the first major upset of the bracket so far. Now, sure, we had Visual Basic beating SQL, but that was a 9th seed versus an 8th seed, not a huge upset. This is a 14th seed beating a 3 seed, so quite the upset just in the first round. Next, we have Go versus Delphi. And both of them are statically typed, so basically what that means is once you set a variable to be a set type, you can't change it. So this is kind of in contrast to programming languages like JavaScript or Python, where you can kind of change the variable on the fly of what it's actually, the type it's being referred to. Now, Go is more kind of focused on the server backend type development stuff, since C and C++, but like C and C++ rather, it doesn't necessarily have a UI toolkit built directly into the language, whereas Delphi is more focused specifically on desktop applications. Now, both programming languages are cross-platform, but Delphi is kind of like Swift in the sense that it's technically cross-platform, but it's mainly just focused on Windows development. It's more of just a Windows thing, kind of like Swift is cross-platform, but it's typically just a Mac OS thing. Now, sure you can, and I have run Swift programs on Windows and on Linux devices, but it's typically more of a Mac OS thing. It's a similar story for Delphi here. It's just swap out Mac OS for Windows. Now, the user base for Go is obviously significantly larger than Delphi, and I'm just going to give Go the win here. I mean, it's more versatile, in its various web, cloud, and server world applications. It's also very performant and has a very modern syntax as well. So Go gets the win over Delphi here. And the last matchup we have for round 1 is C++ versus MATLAB. Now, if you laughed at that comparison, I don't blame you, because quite honestly, this should be a joke, because this one honestly isn't close either. C++, if we want to go back to the basketball analogy here, C++ could probably bench its starters the entire game and play 3v5 against MATLAB, and C++ would still win, probably still pretty comfortably. Because first off, how can you call yourself a programming language when you start indexing at 1 rather than 0? Not to mention the fact that, have you ever tried to use MATLAB? Because if you have, you're probably still waiting for your first program to execute, because how painfully slow the language is. I've had to use MATLAB in the past, which was horrible. It was very slow. If you've ever used Python before, Python is not a fast language by any means. But when you compare, at least in the use cases that I was using MATLAB in, Python looked like C code optimized to the moon and back compared to MATLAB. And that's saying something, because Python, like I said, is not a fast language. If you compare it to something like C or C++, Python gets smoked every day of the week. But yeah, MATLAB, painfully slow, terrible. And unless you're doing like something very specific, like math science based, it's practically worthless. And even with that, if you are doing something math and science based, use a better language. Use Python or something like that. Python is so much better than MATLAB. It does everything MATLAB does, and Python is free. You don't have to pay out the butt for it. And if you want to add additional packages or features, you don't have to shell out more money for it, because yes, you have to pay to use MATLAB. It is the only programming language, if we can even call it that, on this list that is you actually have to pay to use. All the others are free for you to use right now. Now, before I go off on a massive tangent ranting more about MATLAB, I think it's safe to say that C++ easily gets the win here. It's way more versatile, it's way faster, it's just way better in every stretch of the imagination. So C++ wins. So let's look at our bracket now for the Elite 8. So on the left-hand side of the bracket, we have Python going up against Visual Basic, and C# going up against C. And on the right side of the bracket, we have C++ going up against Go, and Rust going up against JavaScript. So those are the 8 remaining in this programming language March Madness. So starting off on the top of the left side of the bracket, we have Python versus Visual Basic. And if we're being honest here, the only reason Visual Basic is even here in the first place is because its opponent in the first round was equally terrible. So I don't think we really need to go into why Python easily wins this battle. Python handily wins and moves on to the final 4. C# versus C. Now, C#, we touched on it. It handily won its matchup in the first round, but let's be real, it was going up against Scratch. There wasn't much competition there. C# is basically Microsoft saying, hey, you know that programming language called Java? And you know how it already exists? What if we made our own version? Now, well, technically, the C# developers claim that C# is not a Java clone. Java developers and the creators of Java would beg to differ. The Java creators claim that C# is an imitation of Java while also falling short of Java's reliability, productivity, it's an imitation of Java while falling short of Java's reliability, productivity, and with security deleted. So C#, like Java, it doesn't necessarily compile directly down to machine code. Similar to Java, how Java needs the JVM in order to function, C# requires its own specific dependency called the .NET framework in order for that to run. And it's not exclusively a Windows programming language, but it's kind of one of those things like Swift is with Mac OS, where yes, it can run on other platforms, but it's typically just Windows-based. Now, obviously, C is a significantly more mature programming language. It runs on practically every platform. It can run on a toaster, literally. It basically, if there is no compiler for the platform specifically that you're trying to run the C code on, there is absolutely a compiler that can cross-compile for the platform that you're trying to run it on. So essentially what that means, if you're not familiar with how compilers work, basically a cross-compiler basically will generate the source code required to run on a different platform. So one of the more common ones of these kind of cross-platform things is, like, for instance, if you want to write a Game Boy game, for instance, you obviously can't compile the C code directly on the Game Boy itself, so you have to use a cross-compiler which will generate the assembly code that is able to run on the Game Boy that you can then load on the Game Boy and run it. Obviously, that code wouldn't work on your typical desktop computer, especially if you're using x86, but the cross compiler allows it to compile for that specific architecture and that specific platform. So if the platform you're trying to run the C code on doesn't have a compiler, there's like a 99% chance that there is a cross compiler somewhere that can compile the C code to run on said platform. So C Sharp, it does require less verbosity when it comes to doing basic things like string manipulation, because if you've ever and it's also object oriented, because that is one of the, I guess, downsides of C, which, depending on how you look at it, could be an upside, is how many steps you have to take in C to do rather basic things, which on the one hand is a fantastic learning experience, since you have to fully understand what's going on under the hood for doing a very basic operation like adding characters to a string. But at the same time, if you already know how to program, having to do all this verbosity time and time again, now sure, you can write functions, but you of course have to write those functions. It's kind of a lot nicer when you can just write, maybe 2 or 3 lines of code rather than 15 or 20 lines of code. But still, regardless, C gets the win here over C Sharp. Probably a surprise to absolutely no one. Next, we have C++ versus Go. Now, up until this point, this was probably the one I had the hardest time picking a winner for, at least up until this point. Some of the future matchups we have were pretty tough as well, but this one was without a doubt probably the most difficult, because both of them have... both of them have their strengths. And if we're going back to the basketball analogy, this is the game that comes down to the final minute. There's like maybe 5 points difference between the teams, and we're at the point in the game where the losing team is fouling immediately when the team in the lead gets the ball, in order for them to shoot free throws and hopefully miss, so then they can get, another possession to try to, get some more points to try to, tie the game up or maybe even take the lead. That's basically what this comparison was, at least how it was in my mind. Because both are compiled languages, both are very fast. Go, of course, has the added benefit of being a more modern programming language with a more modern syntax. C, in contrast, has, the standard template library, which is fantastic. There's a lot of good stuff in the standard template library. But depending on the C++ libraries you're using, they can be quite verbose and cumbersome as well with the namespaces. Namespaces can be kind of annoying in C++, especially depending on how deep you have to go into the namespace. So Go kind of has a little bit of benefit there. Also, Go has a significantly more streamlined concurrency model. So in C++, you of course have threads, but Go doesn't specifically use threads. Just kind of like Swift. Swift doesn't specifically use threads for its threading type applications. Go uses what's called Go routines, which are basically a very lightweight thing, allowing you to run, multiple concurrent tasks without significant overhead. And this functionality is built directly into the Go runtime and the language itself, and all of it is handled by the language. So from the developer's perspective, you really don't have to worry about it. All that kind of logic behind the scenes, kind of like Swift, which is very nice, because having to manage threads and locks and all that stuff can be kind of a nuisance. But also, Go is, again, a lot more concise than C++ is. Now, granted, C++ isn't nearly as bad as C when it comes to how many lines of code you have to write for very basic things, but it's not nearly as good as Go. Now, C, of course, has been around a lot longer than Go has, so it's a lot more mature than Go, and as such, there's a lot more tooling surrounding C++, like debuggers, profilers, build systems, that kind of a thing. Plus, C++ has a bevy of libraries at its disposal, so basically any kind of functionality you might want If it doesn't exist in the standard template library, there's a very good chance someone at some time wrote a library for C++. A couple of the big things for C++, one, of course, encryption. There are countless great encryption libraries out there for C++. The other big one, C++ doesn't have its own graphics anywhere in the standard template library, but there are tons of graphics libraries out there that you can make use of to leverage in your C++ applications, just to name a few. Now, unlike C++, Go has its own garbage collector, which does contribute, kind of takes a performance hit on Go's end, so it's not quite as fast as C++. So for anything like insanely high performance needed, so things like, simulations or, high fidelity trading, things like that, C++ is still typically the go-to because of the added performance that you get by not having the garbage collector. Now, basically anything that Go can do, so, things like web servers, cloud, just general server use in general, C++ can also do. But kind of as we mentioned, C++ also has a lot of other use cases because of the vast number of libraries, they're out there that exist for it. Basically, any kind of game engine is going to be written in C++. Like I said, high fidelity trading system, simulation work. C++ is just a lot more versatile, I think, than Go. And because of that, it's a very tough and close call, because at the onset here, I was kind of thinking about giving Go the win, just because it's also very fast, it's compiled, but also memory safe. But then I kind of got thinking, and maybe it's my bias getting the best of me, but I am going to give C the win here, but only by the slightest of margins. C++ definitely barely eked out the win on this one. So next, and the last one for the Elite 8 round, is Rust versus JavaScript. Now, let me start off this round by asking you a few questions. Do you want fast and speedy performance, or do you want a RAM-hogging bloat machine? Do you want a solid build system and package manager? Or do you want one with more packages than grains of sand and ridden with more vulnerabilities than you know what to do with? Do you want to actually use one programming language, or do you want to use one of the hodgepodge mess of frameworks that get pumped out like cars on an assembly line just to fit a niche use case that one existing framework doesn't exactly meet? So, yeah, I think you can probably see that I have picked a clear winner here. Rust obviously is not only a more performant language, it is more optimized and has a lot less bloat than JavaScript does. Also, it's more secure. It's not dynamically typed. There's the things like the borrow checker and all kinds of stuff built into Rust for memory safety reasons, and also, to detect when things are kind of getting wonky. And kind of as we discussed, JavaScript is designed as a scripting language. It was designed, specifically kind of for web type based applications. And while yes, you can make desktop and mobile applications, as we kind of discussed, it's basically just a browser, an emulated browser to allow the JavaScript to run. So you have to have all that overhead of essentially the browser layer just to get the JavaScript to run. So you have much heavier weight applications that use a lot more resources. It's just a nightmare. Now, Rust, on the other hand, you can actually make real desktop applications and server applications that don't need the web browser as a crutch, basically. Now, also, kind of as we touched on, Rust has a very rapidly growing ecosystem, gaining a lot of momentum. There's a lot of, diehard, I think they're called Rustaceans, I believe, because their mascot is a crab. And I mean, you can even see this. The growing user base and popularity of Rust is definitely evident. Not too long ago, it got incorporated into the Linux kernel. There are now pieces of the Linux kernel, I think mainly specifically drivers, that are written in Rust. And also, I think in one of the more recent Windows 11 updates, I think it was was it 24H2, I think? It was announced that Rust was going to be a part of the Windows kernel as well. So Rust is definitely making moves. And of course, we can't ignore the whole, DARPA thing, the whole tractor, translate C into Rust, basically. So Rust by far has the momentum. It's a way better programming language. And again, Rust, yet again, has another massive upset on its hand. The 14th seed beating the 6th seed to get it into the Final Four. Now, speaking of the Final Four, on the left side of the bracket, we have Python versus C. And then on the right side of the bracket, we have C++ versus Rust. So the 1 seed versus the 4 seed, and the 2 seed versus the 14th seed. So starting off with the number 1 seed Python versus the number 4 seed C, if we're being honest here, this is Python's first real test because it has been on cruise control this entire tournament. And if we're being honest, a programming language like JavaScript could have gotten to this far if it had the opponents that Python went up against, because Python really has had absolutely no competition. First, it went up against R. It's does everything and more than what R does. Visual Basic, the only reason Visual Basic got into the second round was because it was going up against SQL. I mean, JavaScript could have easily probably beaten either of those. In fact, if JavaScript was against either of those, I would have had JavaScript winning. So Python, the fact that it's here is honestly not that impressive because of the competition that it had to go up against. But now it has a real challenger, that in C. Now, when you want to talk about compatibility when it comes to programming language, this is, if we're being honest, this is basically a draw. Because as we touched on with C can basically run anywhere. You can get it to compile on basically any platform you want because C is such a mature language. But because of how widespread Python has become, Python is also basically available on almost any platform you want it to be on. So the idea of one being more compatible than the other is basically a draw. Both have a very wide range of application types that they can be used in. Python does have the added benefit of being a scripting language as well, which is very nice because it helps you to write quick automation scripts, which is a lot harder to do in C if we're being honest. Now, sure, you can write a C program to automate tasks, but Python is going to be a lot easier, a lot more efficient in that regards in terms of automating those tasks. Now, sure, could C be faster in terms of performance once you actually create the automation? Maybe, depending on how you go about executing it, because if you end up going about executing it with system calls, I mean, you're bottlenecked by the system call, so the fact that C's compiled doesn't necessarily gain you a whole lot with everything being a system call. You have that big bottleneck right there. So I think the fact that Python is a scripting language definitely gives it kind of a leg up over C, because you can write graphical applications in Python. You can write graphical applications in C, assuming you get a graphics library. You can write servers in C. You can write servers in Python. You can write basically any kind of application you want in Python. You can write web apps in Python. C, you can, I guess really the only place where C kind of has the upper hand over Python is things like low-level, either embedded systems or operating systems or just kind of any systems programming. C obviously wins there. But unless you're specifically doing that work, I mean, you could, unless you're specifically doing like operating systems work or embedded systems or any kind of systems programming, any other use case where you could kind of think to go with C, you could probably use Python as well. So kind of an even fight there because Python has the scripting, but C has kind of like the systems programming. Now, granted, C is basically the creator of Python. Python was written in C, so Python can't really hold a candle to the raw speed and performance of C, kind of as we've touched on before. But to be honest, it doesn't have to, because the versatility and ease of use of Python can absolutely make up for this. Because, for instance, if you want to prototype out a program, doesn't matter what it is, whether it's a quick application to do something, or you just kind of want to test something out in code just to see how something works, Python is always going to be the faster and easier way to get a basic functioning prototype working compared to C. One of the big benefits of Python is it's a lot simpler to write in. It's programs like pseudocode. There's a lot less lines to do basic stuff compared to C. So your ability to create a quick test program in Python is significantly faster than C. And specifically, if we're talking about prototyping here, the point of a prototype isn't to be the final product. So sure, you might want to write the final product in C, but if you just want to kind of test out an idea to see if it's feasible in code, it's going to be a lot quicker just to spin that up in Python real quick just to see if it works and then translate that over to C. That's something I've done on numerous occasions where I want to just kind of test something out in Python, and then because Python, of course, doesn't have the performance, if I want it to be more performant, then I'll translate it into a more performance-oriented language. But again, the point of prototyping, again, is not to be, insanely fast. It's to, test out an idea quickly, and Python definitely excels at that. Another area Python excels in is the large community around Python and the vast number of modules that exist to basically do just about anything. Basically, anything you want to do in Python is a pip install away if it's not already included in the base Python package. Now, Python also, kind of as I touched on, has the added benefit of being basically reading and writing like pseudocode. It's also object-oriented, which is a benefit over C. C is not object-oriented. Now, because Python kind of reads and writes like pseudocode, it makes kind of maintaining code bases a lot easier because it's a lot easier to read and understand the Python code at a quick glance compared to something like C. Of course, that excludes if you're using like lambdas in Python because lambdas are an absolute disaster, but that's, an entirely different episode. Now, of course, C is absolutely able to dominate. So if we want to take this back to basketball, C is basically completely dominating Python in the paint. Python can't do anything. If C gets into the paint, C's scoring, done deal, game over. But the thing with Python is so versatile. It can score in the paint, it's got a mad mid-range game, and it can also shoot the three. So C is kind of on its back foot trying to defend against all these different offensive threats that Python has. And if we're being honest, I think I have to give Python the win here. Not by much, it's very close, but I think I have to give Python the win just because of how versatile it is and how quickly it is to spin up, test applications and scripting and all that good stuff. Now, it pains me because I love C very much. I also like Python too, but I do have to give the win to Python here. Next, we have the number 2 seed C++ versus the number 14 seed Rust. So here we have the elder versus the up-and-comer trying to replace him. So it is no secret that Rust has been coming for C and C++, also kind of specifically C++. And C++ is without a doubt on the back foot. Momentum is not on C++'s side. C++ has been kind of on damage control, trying to justify its existence as of late, trying to introduce new features to be more memory safe, even though that's basically impossible to do because C++ has to support C and older versions of C++. So yeah, C++ without a doubt definitely does not have the wind in its sails, and both serve very similar purposes. Both, low-level systems type programming languages. Granted, C++ kind of has a wider array of use cases, as we kind of discussed previously when comparing it with Go. There's tons and tons of libraries for C++. It's way more mature than Rust is. But if we're going based on bias in history, C++ would absolutely win hands down. But that's not what we're judging this on. C has a proven track record of delivering performance when it matters and being battle tested to run the most critical infrastructure. So if we're focusing specifically on that historical element, yes, C++ has to win. However, kind of as we touched on a little earlier in this comparison, C++ versus Rust, the years have not been kind to C++. Over the years, memory safety vulnerabilities and decades of trying to manage these code bases have begun to overshadow C++'s dominance and has opened the door to other languages like Rust, Go, maybe to a lesser extent Swift, to basically take the spotlight as the fast and preferred, low level and fast compiled programming language. Now, while I do think C++ is still more versatile and in some cases more performant than Rust, I can't ignore the momentum shift that's happening. And as we touched on, in sports, having momentum on your side can be the difference maker. So while I do think that if you were just comparing apples to apples, versatility, performance, that kind of thing, I do think C++ is the better language because it's losing all of its momentum and Rust has the momentum. I think I have to give Rust the win here. As much as it kind of pains me to say that, I think Rust is going to eke out another win and achieve yet another upset. So that brings us to the final. We have the number 1 seed in Python going up against the number 14 seed in Rust. So we've got the favorite, the number 1 seed, and we got the underdog, the Cinderella story. Well, I guess Cinderella story is, I think, typically reserved for the 16th seed, but R had absolutely no chance. So Rust is going to have to fulfill that role of the Cinderella story. Now, first and foremost, Python is without a doubt far easier. It is a much easier language to learn, a much easier language to build applications with. And as such, it's a lot easier to read and understand Python, again, unless you're using Lambda functions, because those are some of the most unreadable lines of code ever written in existence. But assuming you're not doing a bunch of Lambda functions, it is a lot easier to read, write, and thus maintain than a programming language like Rust. Now, Rust, like C and C++, is going to handily win in the speed category. But like the comparison with C++, Rust isn't as versatile as Python is. As mentioned when comparing it with C, due to the massive number of libraries and modules available to Python, it makes basically doing anything you want with Python a one-click one command line install away from getting the module you need and a couple lines of code for getting the functionality that you want. And it's very effortless to basically do anything from data science, web development, machine learning, automation, and much more. And because with how widely available and well-supported Python is, it's very easy to get any kinds of those applications up and running on basically any platform. Now, Rust, in comparison, its ecosystem is definitely alive and well and is growing, but comparatively, it is still very small compared to Python. So I think because of that, I'm gonna have to go chalk here, and I'm gonna have to say that Rust's Cinderella story unfortunately has to end here, and Python is going to be your champion. So Python, the number 1 seed, does end up winning, at least in my bracket, but I would be interested to know what your bracket looks like, what you thought of my rationales for why I picked the winners that I picked. Would you have picked different winners? Would you have picked different languages entirely or picked a different language to win it all? How would your bracket have looked or shaped out? Would you have chose the same 16 programming languages that I started with, or would you have chosen different ones? All those things, definitely be sure to let me know either in the comments below on YouTube, or you can always shoot me an email at contact@darkassassinsinc.com. Now, before we go, we have to get back to our trivia question for the week, which is, out of the 3 programming languages, Rust, Go, and Swift, they're all memory-safe programming languages that are compiled languages that in part aim to replace C and C++ in historically C and C++ dominated application spaces. But out of these 3, which was created first? So was Rust, Go, or Swift created first? If you said Go, congratulations, you got this week's trivia question correct, and the bonus points was Go was created in 2009, Rust was created in 2012, and Swift was created in 2014. So if you got this week's trivia question or any of the bonus points, congratulations. And I hope you enjoyed this episode. And definitely we had a lot of discussion here. So if you have any questions, comments, topics, or ideas for future episodes, definitely also be sure to either leave a comment down below on YouTube, or you can shoot me an email at contact@darkassassinsinc.com. Now, I think this episode was a lot of fun, and hopefully you did too, so definitely be sure to share it around with all of your friends and family members. Be sure to leave it a rating and review, subscribe if you haven't done so already. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.